So what's up mga ka-ChE? It's Kuya Dale here, and I'm back with the part 2 of the one in operations, subject, filtration, diba? So we left last time with number 15, so let's do our best to include the remaining 10 problems here in this video, no? Okay, so let's dive right into our lesson, diba? So this is number 16. So number 16, I really had a difficulty of answering this because I explained earlier that my knowledge of this is really not extensive, So I've had people that helped me, so I'm going to have a shout out to them, no? So that is my classmate in my review center, no? And my partner also, uh, the teammate in my thesis back in undergrad. It's Daniel Joshua Beha. So yes, and also my teacher in Quantum Review Center, who is the third place, sa board exam, sa top notcher, third place in the November 2019 board exam. He is Sir Chester Tantoco. So he's from UPLB, and he's now teaching at Quantum Review Center. So I just want to give a quick shout out to them. So Daniel Joshua and Sir Chester, thank you for helping me with these numbers, But I have to apologize to you because number 18 in this problem, because I by the time this video is recorded, so we really can't find an answer to this, and we really don't know how to answer that. Okay, so let's we can arrive at that later. Okay, so just read the problem, no? So it requires the use of the root equation, but not really that intense in application of the root equation. So you have filtration of your aluminum hydroxide, ba? And then you have your 50 psi pressure, and then the constant rate. So we are now dealing with CRF na, no? CRF 15 minutes. Okay, and 1/3 of the total volume is obtained during this period. Okay, so given the above, the total filtration time is, okay, so if I may give you the give you the diagram for that. So at this time, CRF, we have the 1/3 1/3 of the volume, 1/3 of the volume collected at that time, diba? So that is the 1/3 of the total volume. So the VF, the filtrate. And then you have CPF, which is, siyempre, if this is 1/3, this is 2/3, diba? Of the VF. And then you have 15 minutes at this time. So, okay, I deleted that. So this is your time, diba? Filtration time. Then this is your P, or your RF. So you have 15 minutes here now, 15 minutes. And then we are to find, we don't know this part, diba? We don't know the CPF part, and then we are told to find the total time of filtration, diba? So that's a bit crazy. So that's how the problem is structured. So now we will have to find the CPF and CRF portion, no? So that we can find the time. Yeah. So let's look at the root equation first. Yeah. So we'll simplify this so that we'll have no problems later. So you have RF, or then you have VV, VF. Then you have so I'm showing you the dili na siya ang differential nga form, no? So because to make this easier, so but this is usually shown in the differential nga form niya. So this is what I've shown you the last video, no? So this is VF and then VE. Okay, so the fictitious volume. So let's turn this into a constant, diba? So because we are not dealing with these values, so we can this as constant, diba? Constant. So let, and I don't know why nga kini siya ilang k over 2. I don't know. K over 2 siya, no? K over 2. This is that kana siya. Okay? So you have now your RF. Yeah, you have K over 2. Then you have your VF. This is VR, I know. VR, and this is also VR because we are talking about here in constant rate nga filtration. So in CRF, this is in CRF mode. Okay, so VR, no, VR, and then you have plus VE, diba? The fictitious volume is equal to the VR over theta R. So combine, no, to one side para makuha ninyo ang K, ang K. So 2VR and VR is VE over theta R. So this is the CRF na portion, no? CRF. This is CRF. So we have to find now the CPF na portion. And I forgot how it was derived, no? But this is the formula of the na siya nga part. This is R, no? This is R. That's the concentrate ng filtration. This is the total VR squared plus 2 VE VF minus VR. Okay, that's it. So now we will have to assume that VE, diba? As I said in the last video, no, is negligible, diba? Because it's so small compared to the volume of the filtrate, diba? So if we let this go to 0, so the CPF nga part, so kanya siya, mahimo na siya 0, diba? So mahimo na siya K, ano siya, then equal to VF squared minus VR squared, and then the CRF nga portion, diba? K is equal to VR squared over theta R. Okay? So theta R na din siya. So if we have to combine, so let's combine all of this so that we will have to we can find the kini man natong required the total filtration time, diba? So if we combine that, we'll have this, no? We'll have VF squared minus VR squared. Then you have 2 VR squared theta F over theta R minus 2 VR squared. Okay, so this is the equation that we will be using all throughout these two problems. Okay, so number 16, so let's delete na lang, no? Delete all the ink on the slide. So number 16, so using, diba, we are given the VR, then it is 1/3, diba? The VR collected, diba, is 1/3 of the total na filtrate collected that's during the concentrate filtration. So we'll have to substitute that to our equation that we have derived earlier, no? So that's VF squared. So just substitute that there, diba? That's squared, and then you have that. This is 15, then 2, 1/3 VF squared. Okay, so shift solve, you have 75 minutes. Okay, so also in number 17, diba? So number 17, if 1/2 of the original filtrate volume of problem 16 were to be collected with the area remaining unchanged, the new filtration time is number 17. We just continue this here, diba? So if 1/2 if 1/2 of the original, so VR, and also 1/2 na lang siya, which is 1/3 of the VF, diba? So 1/2 na lang siya sa 1/3 of the total. Okay, so that's how it is interpreted. So 1/2 of the original, which is 1/3 of the total. So VR karon is 2/3 of the total. Okay, so just substitute that there, no? So VR, no, we substitute there instead of 1/3, mo siyang 2/3, and then time also is 15 minutes gihapon. So please substitute na lang that there, and then you will have your new filtration time of 24.4 minutes. Okay, so yan. And number 18, so number 18, I really don't know how to solve this. So if you know someone who can know this, please comment it below, no? Or please, because I really don't know how to solve number 18. Okay, so this is the time that I will be asking help from you, no? So maybe in the future, how is this gonna happen, no? But please, I sincerely ask for your help in this problem. Okay, let's move on to number 19. From here, it will be easier, no? Easier in the problems, diba? So the number 16 di ay is, diba, 75 minutes. So that's the 30. Okay, 30. So number 19, let's go to number 19. Okay, so we have PNF gihapon. So PNF, diba? So PNF, so that's constant pressure filtration, diba? We have 10 frames, and then you have filtration area. So this is A, 75 square feet, and filter delivers 400 pounds of filtrate in half an hour. So that's 30 minutes of filtration time, diba? If 10 more frames area added to the filter press while the other conditions remain the same, time to produce 400 pounds of filtrate, assuming the RM is the resistance of the medium, diba? Or the filter medium. So whatever filter medium you have, maybe using a filter paper, so assuming 0 ang yung resistance, so unsa ang time, diba? Sa time. So we have to solve for the time. So we have 19, you have the number, you have area 1, diba? So 75 square feet, and then you have the volume of the filtrate, diba? Just this is really the mass, but let's just treat it as the volume. Okay, so it's in the half an hour, diba? And then you have A2, diba? If you have 75, okay, 75, and then okay, if 10 more, okay, if 10 more area, so mahimo na siyang 20, diba? 20 na siya. And then this is 10 frames man, diba? 75. So let's just divide that by 10 so that makuha na to ang factor siyang increase, diba? So added mag 10 frames, so meaning times 2 ang area. So it's just a fancy way of saying it na times 2 ang area. So this is 150. So nothing to worry about, no? It's just simple. Okay. So let's look at the the root equation na pod, no? Sa root equation na pod. So you have a negative p, then GC, then a squared, diba? So a squared, then C, B, let's just that no? So BF or BR really doesn't matter now because kay what we are concerned here is the area, diba? So the area. So we have to find the relationship without because this part are constant, diba? So we'll have to find the relation nga ang time na lang on area, diba? So we have siya. The area is proportional. Area squared is inversely proportional to the time. So muna siya ang relationship, no? Gikan sa root equation, diba? So we'll have to no? So let's just put other variables. So this is time 2, diba? And this is time 1, which is gikan nagapon as dire, diba? So and then you have A, this is A1 and this is A2. Okay? So it becomes easier. So we have time 2, diba? We have time 1, pila may time 1 na to? It's 0.5, diba? And then we have our 30 minutes na lang. Okay, because the times here are in minutes. About 30 minutes, diba? And then we have 75, and then we have 150. Then this is squared. We'll have 7.5 minutes. Okay? So the time is greatly reduced kung i-times 2 nimo ang area. Okay? So number 20. So this is just the same, diba? The same in the part ganina. Okay, ganina. The CPF nga part. So let me delete this na lang. So number 20, diba? So CRF, diba? So CRF, you saw this earlier. You have your K, diba? You have 2 BR squared over your time, diba? Your time. This is R hapon. So okay, negligible filter. So R, this is RM equals 0, diba? And then you have your you have your volume of the filtrate per minute, given the calcium carbonate and water, and if the pressure drop over the cake is doubled, so wala siya. Okay, so we are not finished today, so this is number 21 din siya. Okay, so this is kung for number 20, diba? Number 20, you have your let's just still use the root equation, but this time you have to find the relationship of the volume and the pressure drop. Okay, so how related are they? Okay, so what I have read in the internet, so the pressure drop daw is directly proportional to the square of the volume. Okay, so you have the pressure drop. So let's just create a relationship or an equation out of this relationship, diba? It's V2 and V1. So this is squared. So this is really it's easy, no? So you have to find V2, diba? V2. You have this is twice, no? Twice na siya sa if the pressure drop is doubled daw. So if the pressure drop is doubled, so 2P1 and then so double daw, and then you have your volume, diba? Your volume is V1 is equal to 125 cubic feet per minute. So cubic feet per minute, so just convert that to hour, so times 60 para mo siyang per hour. So you have 7,500 cubic feet per hour. Okay, so put that here, and then do not forget to get the square root of this. Okay, so you will have 10,007. So this is squared also, squared. So per hour. Yeah, that is near letter C. Okay, so let's move on to the last 5 numbers. So number 21 is actually easy. So this is what I have been telling you earlier, the CRF, diba? So CRF, you have this, you have K is equal to 2 VR squared over the theta R, and then you know the theta R, diba? Theta R. Theta R is 30 minutes, diba? 30 20 minutes, diba? And then the V is 30 gallons, diba? And then you are to find the constant same slurry and constant pressure filtration at 50 psig and collected in 20 minutes. Okay, so we have to compare. Okay, so we have this 2VR, diba? And it's 2, and we have 30 gallons, diba? Squared over 20 minutes, you have 90. So wala siya, we'll just not put the anymore, the units. Okay, so in the CPF part, so you have this, so you have VP, we have VP squared over K. Okay, so that's the relationship now. So from the previous equations that we have in the root equation that we have derived earlier, diba? Number 17. So this is the result. Okay, and it's simplified. So you have VP2 VP. So you have 20, diba? 20 minutes na siya, and then you have 90. Then you'll have 42.4 gallons. Okay, 42.4 gallons. And that's letter A. Yeah. So next up is number 22. So number 22, this is really easy. Simple division, diba? So that's 22. So you have to find our y, diba? And then you have to sa tong formula ani. So this is the summation of time. Okay, so you have let's so BF. So unsa ni sila? So you have the time of filtration, time of washing, and then you have the time for the time is doubled di ay siya, no? Time for what's that? Draining, diba? Draining. So draining. So time for draining is twice, diba? Doubled, and then the time for filling is doubled also, and then C. Okay, so that's time for cleaning. So time for draining and filling will be doubled because for draining we'll do it twice. Okay, one for before washing, and then after washing. Filling, you have to fill first, and then you have to fill another the time because you are washing. Okay, time to fill the wash water, that's the second time. Yeah. Okay, so this is just simple. So we have 20 feet cubic feet, diba? 20 cubic feet, 20 cubic feet, and then you have 2. So I'll just transform this to hours na, then times 2 sa time of draining, and then times 2 sa time of filling. You have 25 25 over 60 dayon plus kuan 35 over 60. Diba? Okay, ano? 25, so cleaning time is 25 minutes, dumping, cleaning, etc. is 35 minutes. So 35 over 60. So may answer na, that's 4.4 cubic feet per hour. So that's letter C. Okay, so let's move on to the last two numbers. So last two numbers, I'll have to use a formula here. Okay, yeah, so number 23, this is actually the same, no? The first part is actually the same sa CPF. It's 1/8 of the rate of filtration. So you have 10%, no, volume of filtrate. So yeah, this is actually what we did earlier, no? BF, then 120 minutes. So you have the time of washing is 96 minutes. So you have to find the time of washing kung ang cake is compressible na. So yeah, this is the formula for that. So P2 P1 and then 1 minus S. So S here is the compressibility of the filter cake. So ano siya? Filter compressible sludge. Ano siya? So you have 50 psi na P1 and then 30 psi P2. 50 psi nga P2 and then 30 psi nga P1. So ano siya? 2 is 96, then it's 50, it's 30, 145 over 40 minus 45, and then you will have 127 minutes. Okay, so that's letter B. Okay, and then 24, so filter fabric or filter medium to use in which strong breaking tenacity and strong abrasion resistance are required is, so what do we use? You have to use nylon. Okay, nylon, because this is the strongest of them, I think. Yeah, it's nylon. Then last number, this is actually simple ra, hindi siya kaayo gid, diba? But note ko no, atong gipangita na ko niya is equivalent resistance sa the filter medium. But tanawa ang unit, cubic feet. Di ba? So this is what I said earlier, di ba? The filter medium resistance is actually directly proportional to the fictitious volume, di ba? The fictitious volume. So how do we solve for the fictitious volume na lang? Because the cubic feet ba na. So yeah, so number 25, so we have V2. This is the formula for that, no? V2 is P1 and P2 is P1 and V, this is VE, and then VF. Okay, the filter volume. Okay, so sa first niya volume ana niya, so this is 45, this is 4 psi, ba? 4 psi P1, and then P2 nimo is 45 psi minus 4, and then you have 3 minutes of that. Then we'll have 3 feet of filtrate. So just solve this, and then we'll have 0.293. cubic feet or cubic foot. Certain in. So that's it. That's the end of this video, no? So yeah, please, if you haven't subscribed yet, please do so, and then please click the notification bell so that you won't miss any of my uploads. And then the reference viewer for chemical engineering residential examination, it's still the same, yeah, until we finish this series, no? It will be the same that I will be using. Okay, so that's for this video. I hope to see you on the next one, and please share this to your friends, no? That need this, because I really think we have a lot of people that need these kinds of videos. Okay, so I wonder what will be next. Sa ako ang maybe I will go back to the chemical engineering principles, or we will be continuing the unit operations. But we will cover almost all of the day 2 subjects in chemical engineering here in our series, the tutorial series. Okay, that's it. Bye-bye.